So what we saw in the first part was that you could use limits to find the slope of a tangent to some curve. And here we're just going to take a look in detail how you find the slope of a tangent for a function. And this is the stuff out of box B here, because this is what we actually call the tangent problem. Okay. So I've drawn myself an xy axis here. We're going to have x down here. We're going to have f at x or y up on the vertical axis. And let's say we've got some curve that looks like this. If we're finding the slope of the tangent, we want to find slope. So what we want is delta y over delta x. So we want to pick some point on here, call that x2. We want to have some other point up here, we'll call that x1. And we want to do, let's see, this will be y1, and this will be y2. And this curve that I've drawn here is our function f at x. Now, what I'd said was that what we wanted to do was we wanted to take this formula for slope, delta y, delta x, and that formula gave us the slope of the secant between those 2 points, and we wanted to turn this into the slope of the tangent. So we wanted to take the limit as delta x tends to 0. Okay, we wanted to move the difference between these 2 points, and we wanted to make it really, really small, make these 2 points almost right on top of each other. Or another way of writing this is we could do the limit as x2 goes to x1 of, y2 minus y1 over x2 minus x1. Okay? So we could think of actually taking point x2 and moving it along this curve until it became closer and closer to x1. In this expression rate, this limit that we take right here gets us the slope of the tangent. Okay. And of course, how do we get y1 and y2? Well, usually if we're given the function, we can just evaluate the function at x2 and x1. Okay. So normally we're given the function, we're given some information about x. Okay. So this makes sense so far, right? We're just taking the difference in the function, evaluating the function at 2 points. Okay. So normally when we're given this sort of question, what we are given is we're usually given a value of x, an x value. Okay? So we want a specific value of x where we want to know what the slope of the tangent is. Okay? So we can just say that specific x value, let's say x1 is equal to a, where a is some number, 2, 4, negative 37, whatever. Okay? So the slope of the tangent, let's try this. Slope of tangent at the point x equals a is going to be given by, well, we're going to take the limit as x tends to a. So I'm just replacing x2 by x, okay, to make this more general, and x1 by a. So it's going to be the limit as x tends to a of f at x minus f at a divided by x minus a. Okay. So this is the formula that we are going to use in the next couple of examples to find the slope of the tangent at a particular point. Fair enough? Okay, let's take a look at a specific example here. Find the slope of the tangent to the curve y equals 4x minus 3 at the point x equals 2. Okay, and we'll start by writing out that nice little expression we had before. Limit as x tends to a of f at x minus f at a divided by x minus a. Okay, what's our value of a here? 2. So we're taking the limit as x tends to 2 of f at x minus f at 2 all over x minus 2. And we're told what our function is. Our function is 4x minus 3. So let's just write this, putting in our specific function here. So instead of f at x, I'm going to have 4x minus 3. And I'll put that in brackets. And instead of f at 2, I'm going to have 4 times 2 minus 3. Still all over x minus 2. Now, if x is heading towards a value of 2, like I want to know what this thing evaluates to when x is 2. Can I just sub in x equals 2 to this algebraic expression I have here and evaluate it? Richard's shaking his head. Why not, Richard? Yeah. So we can't just sub in we would divide by 0 on the bottom, and what would we get on the top? We would get 0 minus 0. So we'd have 0 over 0, which, I don't know, is just a mess of bad things are happening there. So we're going to have to work with this algebraically first before we can figure out what the value is here. Well, first thing I can do is I can start simplifying up in the numerator there. Limit as x tends to 2. I can do 4x minus 3, and then 4 times 2 is 8. 8 minus 3 is 5, so this can be just minus 5 over x minus 2. And I can simplify that a little bit more. 4x minus 8 over x minus 2. As I'm writing this, I have to keep this whole limit as x tends to 2 thing out in front there, because I haven't evaluated this limit. All I've done is I've manipulated this expression algebraically. I can get rid of this limit as x goes to 2 once I put in x equals 2 somewhere. And I still can't do that because I'd still end up with 0 over 0. But what I can do is I can factor the top of this. Okay? I can factor out 4 to get x minus 2 in the numerator. This is a good thing because the x minus 2 on the top and the x minus 2 on the bottom now cancel out. So I get the limit as x tends to 2 of 4. It turns out that this limit doesn't depend on x, because after I do the simplification, I have no x's left. So I don't actually have to sub in x equals 4, but this is the stage where I would sub it in, but nonetheless, I get 4. So what does this mean? This means that at the point x equals 2, the slope of the tangent to that curve is 4. Slope of the tangent to 4x, oh, sorry, I should say y equals 4x and it was 4x minus 3. Slope of the tangent to this curve at x equals 2 is, the slope is 4. Okay? So there we've got the slope of our tangent. Fair enough?
So you said minus 3 is minus 2.
And I wrote minus 2? Let's fix that. Thank you very much, guys. Okay? So, simple evaluation of a limit to get a slope. I got one more question that we're going to try, and then we're going to be done. This one's a little trickier, though. Here we want to find the equation of the tangent to this curve at the point x equals 3. Okay? So if we want the equation for the tangent, we want to first find the slope, and then we want to use that slope to find the value for the equation, or find the expression for the equation. All right, but let's start with our expression for slope here. It's going to be the limit as x tends to a of f at x minus f at a over x minus a. We're given our a value here, a equals 3, and f at a is just going to be that function evaluated at 3, which is going to be, well, we can just sub this in. It's going to be negative 9 plus 12 plus 1, which is 4. How is it plus 1?
How is it plus
12?
and negative? Oh, okay. I subbed in like the negative in beforehand.
Yeah, okay. Okay. So yeah, it's, the only negative we have is right here. So let's see what this is going to be. This is going to be the limit as x tends to 3, because that's our a value. F at x is negative x squared plus 4x plus 1. And we want to subtract f at a, which is 4, and divide this by x minus 4, subbing in our value for a. Okay. What do you think we should do next here? There's an easy step that we should do here. Up in the numerator. Even before we factor it out. Even before we do the factoring. Yeah, we should simplify it as much as possible before we do anything to do with the factoring. So we'll get negative 3 there. And Brody's suggestion was a good one here. Next, we want to factor out a negative 1, I think, because that'll make it a little bit easier to work with. Okay. So I'm just going to say we've got to keep our limit here. Factoring out the negative 1 gives us negative x squared minus 4x plus 3 all over x minus 4. Wait, am I writing x minus 4 all the way here? I don't want x minus 4 in the denominator, do I? I should have x minus 3, okay, because my a value is 3. So I'll fix that very carefully. Sorry about that, guys. Okay, so x minus 3, x minus... You're probably all writing x minus 3 anyways. Just letting me go on. Okay, now what should we do with our numerator here?
Now,
Yeah, we can try to factor this thing. So let's factor it. Limit as x tends to 3 still. X and x. This is all over x minus 3. To get that 3, we need a 3 and a 1. We need a negative there and negative there. Oh, and lo and behold, we get an x minus 3 that's going to cancel out. Beautiful. So what we have here is the limit as x tends to 3 of negative x minus 1. Okay? So in this case, our limit does depend on x. We've got an x still in there. So to evaluate the limit, we just sub in x equals 3. So we'll get negative 3 minus 1. So at this point, we can sub in x equals 3. Okay. And we end up with negative 4. Negative 2. Okay. So that negative 2 represents the slope of our line. They were asking us for the equation of the tangent. So we got the slope. Our equation is going to be something like y equals mx plus b. So we can sub in the slope. What we also need are values of x and y that we can sub in. Well, fortunately, we have values of x and y. We know that when x equals 3, y equals f at 3, which we've already evaluated it, and it turned out to be 4. Okay. So we can sub this information in, and we'll get, let's see, 4 equals negative 2 times 3 plus b. So 4 is going to equal negative 6 plus b. B equals 10. So the equation of our tangent is negative 2x plus 10. Did I do this right? Okay. And that's the equation of our tangent.